Welcome to This Explainer. Today, we're going to demystify this massive, frankly incredible leap from basic manual workflows all the way to building full-stack, completely autonomous AI systems in just a matter of minutes. Look, if you've ever felt boxed in by those visual drag-and-drop tools, or if you're just looking for the absolute cutting edge and how software and automations are being built right now, you are exactly in the right place. We're going to explore how Google's anti-gravity IDE and a very specific 5-step framework are just completely changing the game.
So here's our roadmap for today. We'll start with the shift to AI systems, break down anti-gravity and MCP, walk through the BLAST framework, cover deterministic logic, look at triggering and deployment, and finally touch on the future of automation. All right, let's jump right in.
Section 1. The shift to AI systems, escaping the single-agent bottleneck.
We are literally right in the middle of a massive paradigm shift in how we automate our businesses and build software. Think about the past, right? We were totally reliant on manual node-by-node tools where you were essentially just gluing individual steps together. When an email comes in, trigger a CRM update. You were dealing with this severe single-agent bottleneck. But now, we're moving toward these autonomous AI systems where you can have 5, 6, or even 7 agents all working on independent tasks for you in parallel. Instead of dragging and dropping individual nodes, you're effectively coding with plain English prompts to build entire thinking systems all at once. It's a real game changer.
Think of this shift kind of like hiring a superpowered intern. Imagine hiring the absolute smartest person on the planet. If you lock them in a room with a laptop but give them zero context about your business, well, they aren't going to get much done. But when you plug them into a modern AI environment, they suddenly become this 500 IQ copilot who never sleeps, never complains, and just naturally knows everything about your business. They aren't just executing simple tasks anymore. They are actually thinking, reasoning, and building entire systems tailored precisely to your workflow.
Moving on to Section 2, Anti-Gravity and MCP Explained, the engine of modern AI.
So to actually make these systems work, we need a powerful environment and a way for that 500 IQ intern to reach out and interact with the real world. That requires something called Model Context Protocol, or MCP. I want you to think of MCP as your AI's universal remote control. Without it, your AI is totally trapped inside a chat window. But with it, your AI can securely connect to external apps, like your Notion workspaces, your Firefly's meeting transcripts, or your Superbase databases. It can actually reach out, read the data, and actively make changes exactly like a human user would.
Now, using that universal remote, the anti-gravity integrated development environment essentially becomes the fighter jet, and models like Gemini or Claude act as your pilots. And the cool thing is you can swap the pilot out depending on the specific task. Maybe Gemini is better for your visual design, while Claude handles the deep coding. Anti-gravity manages all of this beautifully. It spins up GitHub repositories, sets up your local testing environments, and lets you manage all your files in one place, all while you're chatting seamlessly with your AI pilot.
All right, Section 3, the BLAST framework. This is the 5-step system for full-stack apps.
So to build anything, and we're talking anything from beautiful front-end dashboards to fully autonomous meeting note takers, within this environment, we rely on a highly structured sequence called the BLAST framework. That stands for Blueprint, Links, Architect, Stylize, and Trigger. Whenever you build a full-stack app, you feed this exact sequence to your AI. Why? So it doesn't wander off track. Let's dig into the first 2 crucial steps.
Step 1 is the blueprint. This is where you define your vision and your logic in plain, everyday English before a single line of actual coding begins. You define the North Star, so maybe you want an AI that joins your meetings, grabs the transcript, extracts actionable items, and automatically drops them into a dedicated Notion page. You list your integrations, point out where the primary data lives, outline how you want the final payload delivered, and establish the system's behavioral rules. Establishing a clear blueprint like this is absolutely crucial because it stops AI hallucinations before they even start.
For step 2, links, we establish those MCP handshakes we talked about earlier. The AI reaches out and basically validates, yes, I can actually talk to Notion or Superbase. But listen, here is the golden rule. You must keep your active tools under 50 to prevent what's known as context rot. If you overload the model's context window with too many connections and tools, it gets severely fatigued, honestly just like a human worker at the end of a really long shift. And that's exactly when it begins to hallucinate. Keeping the tool count lean keeps the AI sharp and focused.
Next up, Section 4, Deterministic Logic and Design, Building Reliable Systems.
Now, during the architect and stylize phases, you really have to understand the core difference between probabilistic and deterministic logic. Large language models are naturally probabilistic. They're built for next word prediction. If you ask an LLM the exact same question 100 times, you are going to get 100 slightly different creative answers. But if you are building an app for your agency or a client dashboard, the business logic has to be deterministic. If a user clicks a button 100 times, it literally has to perform the exact same reliable action 100 times. You absolutely cannot have your system falling apart like a cheap $2 suitcase just because the AI decided to be a little creative today.
So how do we fix that? We achieve this reliability through a very strict 3-layer architecture. First is the architecture layer. This contains your technical standard operating procedures, written out simply in Markdown. The rule here is incredibly simple. If your logic changes, you update the SOP before you ever touch the code. Second is navigation, which simply routes the data around without doing any complex thinking. And finally, the tools layer. The key takeaway here is that reasoning stays in the navigation layer, but execution relies on strict, deterministic Python scripts in the tools layer. This ensures the job gets done perfectly every single time.
Once the app actually functions behind the scenes, we stylize. And instead of racking your brain trying to design a beautiful front end entirely from scratch, you can use a brilliant little technique called UI sniping. You basically go to open source component libraries like 21st.dev or CodePen. You find stunning pre-built visual components like a really cool animated chat window or a sleek dark mode dashboard border. You just copy that code and feed it into anti-gravity. Your AI will ethically borrow and instantly apply that high-end aesthetic directly to your functioning app. You lock down the functionality first, then you make it gorgeous.
Section 5. Triggering and deployment. Or, as I like to call it, running while you sleep.
In step 5, trigger, your system really takes on a life of its own. It wakes up on a schedule, let's say every 3 hours. It checks the internet for viral Reddit hooks, or maybe grabs your latest Firefly's transcripts. It processes all that complex logic using Claude or Gemini, seamlessly updates your Supabase or Notion databases, and then pushes everything live. And it does all of this completely autonomously. It's operating smoothly in the background while your laptop is closed and you are fast asleep.
Now, depending on what you build, you will deploy it to different environments. You're going to keep things on your local host if it's just a personal ideation tool or a quick prototype. But if you want background tasks running on a continuous schedule, like scraping competitor websites overnight, you'll deploy that to a service called Modal. And if you've built a public-facing full-stack app that you actually want to share with clients or the world, your AI can automatically package it and push it live to Vercel with just a single prompt.
Finally, Section 6. The future of automation and exactly when to use what.
With all of this immense power available to us via pure text prompting, you might naturally wonder, are legacy tools dead? Well, no, not exactly. Tools like Zapier or N8N are still genuinely great for simple, rigid API connections. If someone fills out a form and you just want a quick welcome email sent out, those visual debugging tools are perfect for that. But for complex, thinking systems, for apps that require deep context, the ability to actually reason, multi-agent parallel processing, and full-stack deployment, for all of that, anti-gravity combined with the BLAST framework is undeniably the future. The technical bottlenecks have been completely removed. I mean it. You don't need a massive team of developers or an endless budget to build $10,000 quality applications anymore. You really just need a solid blueprint and a clear vision. So I'll leave you with this. If code is no longer standing in your way, what will you build next? Thanks so much for joining us for this explainer, and definitely keep learning.